In this video, we're going to take a look at how we use the unit circle to graph the sine and cosine functions. As we travel around the unit circle, so this blue dot is the terminal side of an angle on the unit circle, and then this green dot represents the sine curve. As we travel around the unit circle, we can see that the y value of the unit circle corresponds to the height of our sine function at a given angle measure. So if we're at pi over 6 radians for our angle measure, we can see that the y value is 1/2. And this yellow line is the height of our point on the unit circle, and that represents the height of our sine curve. If we look at our function at pi over 2, the sine at pi over 2, well, the sine of pi over 2 is said to be 1, and that's just the value of y, where our terminal side of the angle pi over 2 intersects our unit circle. We can look at 2 pi over 3, this 0.866, that's rad 3 over 2. Again, it matches up with our y coordinate. 3 pi over 4, again, also matches up with our y coordinate. If we're here at pi, we can see that the y value is 0, right? The height of our graph is 0, and that's because the y value on the unit circle is 0 at pi radians. And this actually holds true for all of our values on the special, or all of our special angles on the unit circle, right? So at 3 pi over 2 radians, so we're 3/4 of the way around a full rotation. The height of our, or the point, the y coordinate where our terminal side intersects the unit circle is -1, and that's the height of our curve. Now, in order for us to complete a full cycle of the sine function, we have to go a full rotation around the unit circle. So we go a full rotation around the unit circle, and we get a full cycle of the sine function. We get all of its positive measures, all of its negative measures. Now, the sine curve is a cyclic function, or a periodic function, meaning that this pattern is then just going to repeat again and again and again and again. And you will see that, right, as we move to 5 pi over 2, it's coming back up to a maximum. It's going to go back down to a minimum and reach its minimum, or sorry, a 0 here again at 3 pi like it did at pi. And then at 7 pi over 2, we're going to reach a minimum at -1, and then back to a 0 here at 4 pi. So you can see that from 0 to 2 pi, we have one full cycle, and we complete another full cycle from 2 pi to 4 pi. And that's how you get the graph of the sine function. You just take the y coordinate of the point where our terminal side intersects the unit circle, and for every value of theta, you plot that. So let's take a look at how we would graph the cosine function. So similarly to the to the sine function, the cosine function is graphed by, instead of plotting the y coordinate, we plot the x coordinate on the unit circle. So when our value of theta is 0, meaning we haven't started moving around the unit circle yet, the x coordinate is 1. And so with theta being 0, our x coordinate is 1, so that represents the height of our cosine function. At pi over 6, you can see the x coordinate is rad 3 over 2. That's what this is. And we get rad 3 over 2 for the height of our cosine. When we reach pi over 2 units, here at pi over 2, the value of x here is 0. We haven't moved any in the x here, which is why the height of our graph is 0. We're going to reach a minimum value for the cosine function when we get to pi radians. That's where it's most negative. So we reach -1 here. And then we're going to come back to an x-intercept here at 3 pi over 2. Again, the value of x is 0. And we'll have completed a full cycle at 2 pi, just like with the sine function. So just like with the sine function, the cosine function has a period of 2 pi and is also periodic. So in another 2 pi radians, so by the time we reach 4 pi, we will have completed another cycle. So we've gone back through, and you see that we, in that time from 2 pi to 4 pi, completed the exact same pattern. So starting at a maximum, then to a 0, then to a minimum, then to a maximum, then to, a 0, then a maximum. and then again, maximum, 0, minimum, 0, maximum. And that pattern will continue for infinitely many cycles in both the positive and negative direction.